Gurukulplex's presentation on algebraic equations. Welcome, everyone. It's my pleasure to present our presentation on algebraic equations. We are about to explore the fascinating world of equations with multiple variables and uncover their importance in mathematics. We'll learn how to solve such equations, study their applications in the real world, and discuss the field's current challenges and future directions. I invite you to come on this journey with us and get ready to be inspired. We shall explore the world of algebraic equations, a significant part of mathematics. We shall deep dive into the various types of equations and comprehend the basics of solving them. Additionally, we shall investigate real-life applications of these equations. By this presentation, we shall discover how algebraic equations can be consequential in our lives. Let us commence our expedition and comprehend the centrality of algebraic equations. Algebraic equations are essential in solving intricate mathematical equations. These equations are capable of expressing the connections between different amounts and predicting real-world events. With the help of algebraic equations, we are able to have a more profound appreciation of the intrinsic patterns and structures of the natural universe. This understanding allows us to make better forecasts and wise decisions in our lives. People have been using algebraic equations to solve problems for centuries. Isolating variables is an essential skill to master. With practice and patience, anyone can learn to solve equations with one variable. Remember, any operations you do on one side of the equation must also be done on the other side in order to keep the equation in balance. Understanding and solving algebraic equations with two variables is an integral part of mathematics. The process of isolating and substituting one variable into the other equation enables the resolution of problems with multiple equations and two variables. This technique can be a gateway to further explorations in algebra and lead to intricate findings in mathematics. Algebraic equations with three variables can have a complex structure that can be tricky to solve. To find the values of the variables, we can use either the substitution or elimination methods. These methods allow us to manipulate the equations in a systematic manner, making the process easier and more efficient. With these tools, we can understand and appreciate the immense importance of algebraic equations with three variables in mathematics. Algebraic equations with multiple variables are of vital importance to advanced mathematics and play a key role in the sciences, engineering, economics, and computer science. Solving these equations can provide a deeper understanding of the world and enable us to develop innovative solutions for complex issues. They offer a way to model and analyze complex systems, allowing us to create new approaches to challenging problems. When it comes to algebraic equations with multiple variables, isolating each one is essential. Utilize the properties of equality and combine like terms to achieve this. Incorporating known values into the equation can aid in simplifying and checking for errors in the initial equation. This will help you to get the desired result. Algebraic equations with multiple variables are widely used in image processing, which is the manipulation of images to enhance their quality or extract information. This process involves using various equation-solving techniques to identify elements and patterns within an image. These techniques are employed for a variety of tasks in both commercial and non-commercial applications. For instance, equations can be used to determine the position, shape, and other properties of objects in an image, or to segment and classify pixels in an image. Furthermore, equation-solving techniques can be employed to identify and detect objects in an image, and to compress and further process images. In short, algebraic equations with multiple variables are essential tools in image processing, and their applications are numerous and varied. The linear equation with multiple variables is the foundation of algebraic equations. A graphical representation of these equations in a coordinate plane provides an accessible way for visual learners to understand them. Not only do they help us get the solution of an equation, but they also show us the importance of understanding the relationships between variables. In the example provided, we can see how the equation 2x plus 3y equals 12 can be visualized to depict the relationship between the variables x and y. Quadratic equations with multiple variables are a versatile and impressive feature of advanced mathematics. They involve the interaction of distinct variables raised to the power of 2, and can be used in modeling complex systems and predicting phenomenon. To take the example of the equation x squared plus bxy plus psi squared equals d, a, b, c and d are constants whereas x and y are variables. Solving an equation of this type requires a fair amount of analysis and manipulation, but fortunately there are a few approaches to help make this easier. The quadratic formula allows one to find the roots of the equation by plugging the coefficients into a formula. Alternatively, one can use the method of completing the square, which involves isolating the variable terms, then solving for the variables. Cubic equations with multiple variables are a complex and powerful aspect of algebraic mathematics. Solutions to such equations involve manipulating the variables and using algebraic techniques such as factoring, substitution, and other trained methods. Their use range from creative problem-solving tools to their application in various physics and engineering fields, having a significant impact on modern science and technology. Understanding cubic equations with multiple variables is essential for anyone interested in pursuing a career in physics or engineering. Polynomial equations with multiple variables are an essential tool in advanced mathematics, used to model complex systems and phenomena. These equations involve terms of different degrees, for example 3x squared plus 2xy, y cubed equals 0, a polynomial equation with two variables. Although challenging, there are techniques and strategies available to simplify the process of solving these algebraic equations. Nonlinear equations with multiple variables can be challenging to resolve without taking resort to numerical methods and computer simulations. As an illustration, the Lotka-Volterra predator-prey model portrays the relations between two species from an ecosystem. This model involves two differential equations, each occurring for one species, and also factors such as birth rates, death rates and predation are taken into account. Solving these equations gives a better understanding of how the populations of the species change over time. Solving systems of equations with multiple variables is an integral part of algebra and can be seen in a variety of real-life applications. Such systems consist of multiple equations with various variables, and finding the solution requires a simultaneous approach. The production possibility frontier model of economics is a good example of this, used for trade-off analysis and resource allocation decision-making. Mastering this concept can be a complicated task, but it is important in order to make accurate decisions in real-world scenarios. Systems of linear equations with multiple variables are essential to many fields of mathematics, from algebra to machine learning. They provide a fundamental method to solve large and complex problems, such as finding the parameters of a neural network or the set of parameters that minimize a cost function. To accomplish this, we must use techniques from linear algebra. We can express the system of equations in matrix form and use row operations to solve for the parameters. Gaussian elimination and Lie decomposition are two popular methods for solving these systems of equations and enable us to quickly and accurately solve for the parameters of a problem. Solving systems of nonlinear equations with multiple variables requires advanced math exploration. There are three methods that can be applied to accomplish this: substitution, elimination, and graphing. In substitution, one equation is solved for one variable and then plugged into the other equation. Elimination adds or subtracts the equations in order to remove one variable at a time. With graphing, the equations are plotted on a coordinate plane and the intersection points are found. Algebraic equations with multiple variables are at the forefront of mathematics and continue to bring new opportunities and challenges to the field. With advances in computing power and machine learning algorithms, researchers are able to tackle increasingly complex equations with greater accuracy and efficiency. Furthermore, the use of algebraic equations has broad applications, making it an area ripe for interdisciplinary collaboration. Going forward, the field of mathematics will need to continue to collaborate and grow in order to solve the challenges and take full advantage of the opportunities presented by these equations. Dug deep into the fascinating world of algebraic equations and the importance they hold in mathematics, we learned how to solve equations with 1, 2, 3 and multiple variables. Examining the various types of equations such as linear, quadratic, cubic, polynomial and nonlinear equations, we also studied systems of equations and the solutions associated with both linear and nonlinear equations. Algebraic equations with multiple variables are essential for further advancement in mathematics as well as in applications such as engineering, physics and economics. Solving these equations demands strategic thinking and problem-solving skills, and there is much progress yet to be made by exploring new techniques and methods to tackle the problems of today and the future. On behalf of Gurukulplex, thank you for your attention and invite you to continue the conversation.